All right, let's jump right in. We're going to be looking at one of the most, and I mean truly one of the most beautiful and shocking equations in all of mathematics. It's Euler's product formula. And really, it's a story about a hidden link between two parts of the math world that seem like they should have nothing to do with each other. So get this. On one side, you've got a product, a multiplication, that only uses prime numbers. 2, 3, 5, 7, and so on. The absolute bedrock building blocks of every other number. And on the other side, a sum, an addition that uses every single positive whole number, 1, 2, 3, 4, all the way out to infinity. So the immediate question is, how? How in the world can multiplying this very exclusive club of numbers, the primes, end up being the exact same thing as adding up a series that includes all the numbers? It feels like it just can't be right. But stick with me because we're going to pull back the curtain on this amazing mathematical magic trick. To figure this out, we have to zoom in on the left side of that equation, the part with all the primes. We're going to take it apart piece by piece and see what's really taking away inside. Okay, I know that whole expression looks a little intimidating. An infinite product can be a lot to take in. So let's not worry about the whole thing for a second. Let's just grab one of those individual terms, the one for any prime number we want to pick, and we'll just call it p. Now here's the cool part. Each of these little pieces is basically a compressed file. It's got a secret identity. When you unzip the term for just one prime, p, it expands out into a whole infinite sum. You get 1 plus 1 over p plus 1 over p squared plus 1 over p cubed, and on and on and on. So that clean-looking product is actually a product of infinite sums. So if that's what one piece looks like, what happens when we start multiplying all of them together? The infinite series for the prime 2 times the one for the prime 3 times the one for the prime 5. What does that even create? Well, let's start small just to see what happens. If we only multiply the series for prime 2 and prime 3, we start building a brand new sum. And how do we build it? We just pick one element from the 2 series, pick one from the 3 series, and multiply them together. What you end up with is a sum where every term looks like 1 over some power of 2 times some power of 3. Okay, now let's scale that idea way up. When you do this for every single prime number that exists, you create this absolutely gigantic, sprawling sum. And every single term in this new sum is a unique mix of prime numbers raised to different powers. It looks like total chaos, right? But there's a beautiful, hidden order to it all. And this is where we find the secret code, the key that unlocks this entire mystery. It's a fundamental rule about numbers that brings perfect sense to all that chaos we just made. It's called the fundamental theorem of arithmetic. And what it says is incredibly powerful. It says that every whole number bigger than 1 can be built by multiplying primes in one and only one way. It is literally a unique fingerprint for every number. Take the number 12. Its prime recipe is always 2 2s and a 3 multiplied together. Always. There is no other combination of primes that will give you 12. Or look at 72. It's always 3 2s and 2 3s. Every single integer has its own exclusive prime code. And the word that makes this whole thing work, the absolute magic word, is unique. Every number gets its own identity card made of primes because it can be written in only one unique way. No repeats, no overlaps. Okay, so now we have our two huge pieces of the puzzle. We've got that giant sum we built from all the primes, and we've got this unbreakable rule about their uniqueness. Let's put them together. And here it is. This is the big aha moment. Remember that giant sum we generated? Well, it turns out that every single term in that sum corresponds to the unique prime fingerprint of exactly one integer. Every term is a prime code. And because of that fundamental theorem, every integer is represented once and only once. So that's the grand connection. The product over primes, when you expand it all out, doesn't just equal the sum over all the integers. It literally becomes the sum over all the integers. They are a perfect one-to-one match. The prime numbers, through multiplication, perfectly build a representation of all the whole numbers. It's incredible. So why is this such a big deal? Well, this wasn't just a clever party trick. Euler's formula built this incredible bridge between two completely different areas of math: number theory, the study of primes, and analysis, which is all about infinite series and functions. It gave mathematicians a whole new, powerful way to study the deep, mysterious patterns of the prime numbers. And it really just leaves you with this amazing thought. This formula revealed a hidden structure, a deep connection that was hiding in plain sight. It just makes you wonder, what other beautiful secret relationships are still out there, buried deep in the language of math, just waiting for someone to find them?